Today we are going to be covering, again, 5.6 and 5.7. I think the 5.6 material is pretty quick, it's pretty straightforward. I think it sounds a bit more difficult, it might look a bit more difficult than it actually is, but essentially this is a section where you're going to be wanting to use your calculator more compared to previous ones. So working with equations with decimals. So what is different? What's really changing in this section compared to its previous ones? Almost nothing, basically. All the previous rules that we have for adding, subtracting, multiplying, dividing, solving equations, properties with equations, how we go through them, our order of operations with that, everything is staying the exact same. The only difference is now we're going to have different, slightly grosser numbers, primarily being decimals. We could have one digit or one decimal place to them, 2 decimal places, 4, 5, whatever. This is pretty much the only thing that's going to be changing. We just have grosser looking numbers. That's about it. The primary difference that does show up with these, however, is when we are asked to approximate our final answer. And problems will generally tell you, okay, round your answer to the nearest tenth, hundredth, thousandth. Round to the nearest, round to 2 decimal places, round to 4 decimal places, 1 decimal place, something like that. And the big part that comes up that trips people up with this section is when they round a problem. And we'll go through, I'll probably go through 1, maybe 2 of these. But you do not want to do any kind of rounding whatsoever until you get to the very, very, very final answer. That's the biggest part that trips people up in this section is, well, partway through the problem, I might get a kind of long decimal that shows up. Write it out. Write the whole thing out. You're going to let the calculator do a bunch of the work for you, but write it out. Only round decimals when you get to your final answer in the problem. And again, the problem should tell you what that's going to look like. In some instances, and this would primarily be in classes beyond this one, if nothing is given to you for where to round to, then rounding to the least number of decimal places provided in the original numbers is the best strategy. So you're going to look at your original numbers and say, okay, what's the smallest number of decimal places that any of them have? And that is what you are going to round your final answer to. I don't plan on having you guys do anything like this on the test. I plan on telling you guys round your answer to 2 decimal places or round your answer to the tenths or the hundredths, something in that regard. But this is a note for, I think it's primarily in a lot of the science classes, chemistry, where this shows up quite a bit. Where we're rounding and we're not explicitly told where to round to. And again, even with that, they have their own rules with that they may or may not want you to follow or anything like that. So again, I think that's the trickiest part with decimals. Where do I round to and how do I round it? Anything like that. Okay. So we're going to go through at least one example. I might go through 2, but we'll go through our first one here. Again, not a whole lot is changing. Basically nothing is except for our final answer, really. And again, as you're going through these, because we are going to have grosser numbers, you are more than welcome, and I highly encourage you use a calculator when you're adding, subtracting, multiplying these numbers together. Okay? So I'll jump us over to the whiteboard and we'll go through 1 or 2 of these examples that we have here. Okay. So our first example that we are working with, oops, come on. There we go. So first one that we have negative 6.37 plus 6.3 times x plus 4.9 equals negative 1.33. And again, check to make sure you have everything written down correctly. Don't make my mistakes as I've done previously in the past, where you write them down wrong and everything falls apart that way. And it looks like, yeah, we've got everything down there. So just like we did with our previous problems, we're like this. We are simplifying the left-hand side of the equation down using PEMDAS, And we're simplifying the right-hand side of the equation down before we start moving things back and forth. So on the left-hand side, I can multiply numbers through there. And I'm going to get 6.3 times x. It's just going to be 6.3x. We have 6.3 times 4.9. And again, I don't know what that is off the top of my head. I know it's going to be a positive answer, but just use your calculator for that. 6.3 times 4.9. And that's what I'm doing off screen here. I'm getting 30.87 equal to 1.33. So again, I'm looking to see, can I simplify things down any further? I can. I have numbers, just constant terms on the left-hand side. I have a negative 6.37 plus 30.87. I can combine those together. And again, apply your calculator with that, because decimals are gross, in my opinion. At least they can get pretty gross. When we add those together, the integers, the constants there, I'm getting 24.5. Okay. Now the left-hand side is as simplified as it can be. The right-hand side is as simplified as it can be. And now I can start adding or subtracting, multiplying or dividing things to both sides of the equation. I want to get the variable terms all by themselves. So I'm subtracting this 24.5, getting rid of the constant terms on that side. Let's cancel over on the left. I get 6.3x is equal to, and then just apply your calculator again for adding or subtracting, multiplying, dividing these things together. Oops. Negative 1.33 minus 24.5. I'm getting negative 25.83. Now last but not least, I want just x, so I need to get rid of that 6.3. 6.3 is attached through multiplication, so I'm dividing both sides by 6.3. X is equal to, again, I'm just plugging this into my calculator, negative 25.83 divided by 6.3. I'm getting x is equal to negative 4.1. And we're done there. So again, the only real difference that we have showing up with these problems in 5.6, the only difference is now we've got decimals. I've got really gross decimals showing up, and you just want to use your calculator more. That's about all that's really changing, and all I would really recommend changing in your process. Our methods that we learned, the suggested process I gave you guys from, I think it's 3.5, then we did a little bit of that with 4.8, I think it was, with fractions. That process is going to stay the exact same. Nothing's really going to change on that at all. Okay? So not a whole lot new from 5.6, just different numbers showing up. So I'm going to jump us back to our lecture notes because 5.7 is some actual new material. We're going to jump over there. Okay, so 5.7, this is where we get to some new stuff. We get to work with our introduction to square roots. So square roots, and as a more general sense, radicals are basically the opposite of exponents. So we have, recall based on our first part that we have up here, that x squared is the same as saying x times x. It's something raised to the second power. It's something multiplied by itself that many times. So the square root, quote unquote, undoes a number raised to the second power. And again, this is specifically for a square root in the second power. Essentially, it's just undoing what we already get as a calculation. Now, because radicals are related to exponents and undoing a power, we refer to them and we work with them in the exponents part of PEMDAS. So I've seen some people slightly alter PEMDAS to be PERMDAS, put an R right next to the E and write it out that way. You don't have to. But just know that radicals, square roots, cube roots, whatever those may be, those are related to exponents as we're going through and following the PEMDAS process. So our main definition that we have for our square root, if we have a to the second power, it's equal to b, then a is called the square root of b. The idea behind it is this is the main number that we get that when we square it, we get a value coming out from. I've heard it likened primarily to the idea of a plant, or this is the root that the number or answer grows into when we square it, or we cube it, or we fourth it, something in that regard. So let me get to some parts. So a couple examples that we have showing up here. And there's a very subtle part that I think is unfortunately lost when we are going through it in this regard. But finding the square roots of a given number. So if I'm asking you guys, what is the square root of 81? Now, as we have it listed here, we have 9 and -9. Now, a lot of people, the initial gut reaction is, well, it's just going to be 9. And again, that's not wrong. However, again, think back to our definition that we have here. I have something raised to the second power. That's going to give us our answer. If I have 9 squared, it's going to give me 81. If I have the quantity -9 squared raised, then my answer is also going to be 81. A negative times a negative is a positive, and 9 times 9 is going to give me 81 that way. So this is one of the extraordinarily subtle parts of when we're being asked to find a square root or find a positive or a negative square root. If we are just told, find the square root of a number, we need to find both the positive and the negative square root that goes along with it. And there's a big difference, which we'll get to a bit farther down here, between being asked for the square root, the positive square root, and the negative square root. Those are 3 different questions with 3 different answers attached to them. So if we're looking at 144, what's the square root of that? Well, again, we have 12, and then we have -12, because -12 raised to the second power, the same as saying -12 times -12. A negative times a negative is a positive, and 12 times 12 gives us 144. If we're working with 0, what's the square root of 0? Well, again, anything times itself. That's what we're looking for our square root here. And 0 times 0 is going to give us 0. So the square root of 0 is just going to be 0. And then the square root of -9. This is one where there is no square root of this. There's no answer to this. For anyone that has heard of it or is familiar with the idea behind these, this is where we can get imaginary answers coming in, or imaginary numbers. However, for the purposes of what we are going to be going through for 5.7, we are not going to be utilizing imaginary numbers for this. If you're familiar with those and you do want to write those out for yourself, just be aware that I can't remember if WAMAP is set up to accept I in the final answers for these or not. So just be aware of that. But in terms of actually calculating this out, what's the square root of -9? There is none. There's no square root of a negative number. Okay, so again, this is the main important note that I want to make for you guys here. If we are asked to take the square root of something and no radical is initially given to us, meaning no symbol that we have here of a radical, which we're going to get to in a bit more detail in a second, then we absolutely must list the positive and the negative answer. Because we do not know if we're being asked about what's the positive square root, what's the negative square root. We're just being asked, what is the square root? Which means we need to list both possibilities. And if we do not do that, we're going to lose points. So we need to answer as specifically as we can based on the answer that we are being asked. Okay. So I'm going to zoom us in here a little bit because I think Make sure we're looking at this better. So working with notations with square roots. It's referred to as radical notation, probably due to the fact that we are going to be using this symbol that we have showing up here. So our square root of x is where we are going to be kind of referencing with a couple of our definitions that we're going to have showing up here. We're going to assume that x is a number greater than or equal to 0. So that way we can actually have an answer showing up in this. So the symbol that we have showing up, this kind of squiggly looking one here, is referred to as the radical. So that's where we get this radical notation from. Okay, so we see it showing up here, something with no radical given, and you'll see it referred to in later classes as the radical as well. So this symbol, that's the radical. The thing that's inside of the radical is referred to as the radicand. So in this case, it's going to be x. So kind of mentioned it earlier on with our number 4 here, but we are not going to have an answer if the radicand to a square root is negative. Never going to have a real answer to that in any way, shape, or form. It's impossible to find one. Okay? So if you ever see that showing up, I have the square root of a negative number. I can't have a real answer. It's impossible. So this is getting into the forms of how to solve or answer a square root question. And this is going back to our note that we made here. I made here for you guys. So this is where it's differentiating between, I think this is a very understandable part to get confused on. Well, when do I list both answers? When do I list just the positive? When do I list just the negative? Those 3 potentials, and then trying to clarify that here with this set of notes that we have. So our forms for how to solve or answer square root questions. If I have the square root of b, first one that we have here, this is asking for the non-negative or the positive square root of b. So in this instance, if I'm given the square root of b, I just list the positive answer. In the instance that we have here, negative square root of b, this is asking for the negative square root of b. So in this instance only, we're listing just the negative answer. And then the instance where we are not actually given a radical of any way, any type whatsoever, then we need to list both the positive and the negative. So if nothing is listed, give both answers. If one of these is listed, then you're just giving one answer, and it's all based on the sign that's out front of the radical. If there's nothing that's given, like our first one that we have here, it's assumed to be positive. If there is one given and it's a negative out front, then again, it's assumed to be negative, and you just list the negative answer in there. Okay? This is a very understandable part where people get tripped up on. So take that extra bit of time to get that organized for yourself and straightened out with how many answers am I going to have based on what the question is asking. That extra little bit goes a long way. Plus it saves us points, which I think we all want on tests and homework and whatnot too. So we kind of touched base on this, but again, referencing again, radicals with PEMDAS. We simplify the radicand of a radical during the parentheses part of PEMDAS, following all the regular rules of PEMDAS inside. And this shows up again in a few instances. We'll see an example or two of this. But a lot of people jump to wanting to automatically just apply the radical right off the bat. And we don't want to do that. We need to simplify the radicand first. We're going to find in a lot of instances that makes life a heck of a lot easier for us in that regard. So do the radicand first. That goes with the parentheses. Once we have finished the parentheses portion, then we move on to the exponents. And radicals are included under the exponent part of PEMDAS and can be completed alongside exponents in that kind of a tier structure that we have. So again, I'll draw this out from, so we have it. So if you are going through PEMDAS, again, I think of it as a tier system because that just makes, oops, there we go. Makes it be easier for me. So we start inside the radicand if we can finish anything or simplify anything inside there. Then we work with the exponent part, which is where we actually apply the square root to whatever answer we get from inside our parentheses, or inside the radicand, I should say. And then we move on to anything else from there. And again, we'll go through a couple examples of each of these to show this to you guys. Where's our spotlight? There we go. So working with radicals with fractions and decimals. When working with fractions, you can find the square root of the numerator and denominator separately, and then bring everything back together as a single fraction answer. So you don't need to work with finding the radical of the square root for the entire fraction all at once. You can separate it out and do it in parts. It's very helpful. I highly recommend you do that with a lot of these fractions, because they can get a little gross and a bit overwhelming at times without doing that. Excuse me. Decimals are a bit trickier, primarily from the standpoint of I think they're harder to find the actual square root of if we have a perfect square that's showing up. My general rule of thumb, if you have the square root of a decimal, just use your calculator. I have no problem with you guys doing that. I think going through and figuring out how to work with and find the square root of a decimal is just way too much unnecessary work and not something that I'm going to require you guys to do. So if you do see a decimal showing up with radicals, again, just use your calculator for it. I'm A-okay with that. So we're going to go through a couple examples with this. Let's on to our next page. So these are the 6 examples that we have, and these are what I'm going to go through over on our whiteboard. Okay. So we're told with pretty much all of these to simplify. 4 is a bit different, but we're going to go through these on our other page. So we'll jump over to the whiteboard, and we'll clear this out. Okay. So our first example that we have, we are told to simplify the negative square root of 121. So I'll give you a quick second here. I'm going to ask it hypothetically and give you a couple seconds to think on your own. Am I going to have one answer to this, or am I going to have 2 answers to this based on what I'm being asked and what I've been given initially? So take a quick second, think on it on your own. And I'm being asked to find the negative square root of 121, which means I'm going to have only one answer showing up. So it's also going to be a negative answer because we have the negative square root of that. So my answer is going to be a negative. We can plug this into our calculator. I'll actually bring up the calculator here to show you guys what this looks like and how we do that. I think this is worth seeing. So our answer to this is going to be negative 100, or sorry, not negative 100. Our answer is going to be negative 11. I'm going to go through, I'm going to show you guys how you can plug this into your calculator so you can go through and do some of these calculations on your own. So I'm going to jump us over to graphing calculator app that I have. So if you have your graphing calculator, now is the time to get that out. Just I would highly recommend getting that out. Clear the previous stuff that we have here. So again, our previous example we were just working with, we were trying to find the negative square root of 121. So the way we're going to do that, going to the bottom of our screen, we're going to hit the negative button. Again, negative versus subtraction. We know the difference between them as we write them down. Calculator is dumb. Our bottom one is the negative. On the right side is the operation subtraction. These are very, very different. So we want the negative option. So we want the negative square root. If we see right over here on the left-hand side by this x squared, it's our blue option. So I'm going to go to second and square root. Yours might look slightly different from this in that yours might have a parentheses showing up, which is fine. It's just a matter of a different form of a calculator, or different calculator display, I should say. And now we're going to enter in the radicand that we have. So 121. If you have a display similar to this, I'm going to hit right on this directional pad to get outside of that. If you're someone who has a graphing calculator that puts a parenthesis in front of the 121, then close the parenthesis right down here. So again, this is just different types of calculators that you have. So if you have parentheses showing up, close the parentheses and then hit enter. And we get negative 11. So again, that's negative at the bottom, second square root 121. Strip out of the radicand, and then hit enter. We got our answer. So that's how you can use your calculator to go through and solve these things as you're going through them. And again, I highly recommend you use this especially for the gross numbers that show up with this and decimals. So we'll jump us back to our whiteboard that we have here. We have our answer for our first example. I'm going to close this emulator because it is slowing down and causing the computer to lag a little bit. So I'm closing that. We can go through more examples of working with that at the end if necessary, but I want to make sure I can actually get through this stuff and not have the computer glitch out on me. All right, so working with our second example, we're told to simplify the square root of, oh, come on, there we go, 81 over 49. Something like that. Now again, as I told you guys as you're going through this, you can actually separate this out and work with finding the square root of the numerator and the square root of the denominator, and then bring everything together as a single fraction. So you can rewrite this for yourself as the square root of 81 over the square root of 49. Work with those separately. So the square root of 81 is 9, and the square root of 49 is 7. And then again, we have a fraction answer. We are always asking ourselves, can we reduce this fraction down any further? And no, we can't, because 7 is a prime number, and these things don't have any other factors in common with one another. So we have our answer there. So moving on to our third example that we have here. We're told to simplify the square root of 0.36. This here makes it a bit better looking. Okay. Now this is one, okay, I've got the square root of a decimal showing up. And again, my recommendation, just default to using a calculator for it. There is nothing wrong with doing that, especially with decimals. Anything that isn't a perfect square, yeah, you can default to using a decimal for that, or using a calculator for that. So again, I'm gonna go through that same process that we went through previously, just off screen. I'm going to go in and do the square root of 0.36 in the calculator, because again, it's a bit gross to work with this and try and do it by hand or mentally. I think it's more of a challenge than it needs to be. So our answer is going to be 0.6. So go through that. So again, just use your calculator. I'm fine with that. I'm fine with you doing that on the homework. I'm fine with you doing that on the test. Nothing wrong with that. Number 4 is asking us to find the square root of 100. Now again, this is the instance where, and answer this to yourself mentally, am I going to have one answer to this, or am I going to have two answers to this based on what we have been given and what we're being asked to find? And our examples that we had. So I'll give you guys a minute or a couple seconds here to think on that. And in this instance, we are going to be having two answers. We are told to find the square root of 100. We are not told if that is the positive square root or the negative square root. So that means we have to list both the positive and the negative answers to this. You say, okay, well, what's the positive square root of 100 and what's the negative square root of 100? Because we don't know specifically which one they're asking for, so we have to give them both. So the square root of 100, the positive square root, is 10. And the negative square root is going to be negative 10. So the square root of 100 is going to be 10 and negative 10. And again, this all is because of the fact that we are not being told anything about, are we finding the positive or the negative? We're just told, find the square root, which means we have to list everything. It's a very subtle part in the wording, a very subtle part in information that we are given, but we have to follow through with doing that. Okay. Now I'm going to jump us to example 6. I think it's a better one with taking a look at using PEMDAS with this. And I'm going to end things there for today just because of our looking at our time. So we are simplifying 30 minus the square root of 6 squared plus 8 squared. Again, we are told to simplify. We're using PEMDAS. That's our go-to with that. So based on the notes that we have, we are working with everything inside the radical, meaning our radicand first, to simplify everything down. We treat that as though it's a part of the parentheses step. So I'm only looking inside here. And inside the radicand, I have exponents. I have 6 squared and I have 8 squared. So 6 squared is going to give me 36. 8 squared is going to give me, what's that, 64? And again, I can still simplify this radicand further, so I still have to do that. We're not out of the woods yet with our parentheses and our process that we have. So 36 plus 64 is going to give us 100. And now I cannot simplify the radicand any further. So my parentheses step, done. Now I apply the exponents. Remember, our radicals fall under the exponent portion of our PEMDAS, our order of operations. So the square root of 100 is going to give us 10. I'm keeping the sign out front. So our exponents are now done. Multiplication and division, I don't have any of that going on. Addition, subtraction, I have 30 minus 10. It's going to give me 20. I cannot do anything else from there. So I have my final answer, 20. Okay. So make sure as you are going through these and you are told to simplify if you have stuff going on inside of the radical sign, again, stuff going on inside our radicand, you simplify inside here first. Make that all the way down to just being a number, and then you apply the radical on the outside to that. Okay? So that is our lecture notes for today with 5.6 and 5.7. I'm going to end the recording here. I'll take any questions you guys have afterwards.